is CORDIScovery. Hello and welcome to this episode of CORDIScovery with me, Abigail Acton. Artificial intelligence. Are we heading for a dystopic future or one in which labour force is relieved from menial tasks? Machine learning is second-guessing us. Is that making our lives easier? Or is it intrusive? Corporates are hoovering up content to train large language models in ways that are hard for users to control. It's clear AI is huge, but good huge or bad huge? That seems to be up for debate. There's no doubt that AI and related tools are pushing back the boundaries of research. Today, we do have some clarity, at least when it comes to our three projects, all of whom have received EU research and innovation funding. Our three guests are using these tools to develop new technologies and make discoveries that would have previously been impossible. We're looking at the way in which AI is pushing back the boundaries of knowledge to improve the prevention, treatment and rehabilitation of stroke patients, to give a voice to the previously unheard women of historical Ireland, and to develop a small, powerful biothreat detection system to save lives. John Kelleher is the director of the ADAPT Research Ireland Centre for AI-driven Digital Content Technology and Professor of Computer Science at Trinity College Dublin. He focuses on harnessing AI to enhance the understanding and treatment of complex medical conditions. Hello, John. Welcome.
Hello, Abigail. I'm delighted to be here and very much looking forward to our discussion.
Jane Ohlmeyer, Professor of Modern History at Trinity College Dublin and former chair of the Irish Research Council, is an expert on new British and Atlantic histories. She is applying AI to the recovery of the lived experience of ordinary, non-elite women in early modern Ireland. Hello, Jane.
Hello, lovely to be here.
Lovely to have you. Béla Mihalik is a senior developer at Ideas Science in Hungary. He specializes in the application of AI and deep learning to develop novel tools that can rapidly screen potential biothreats in the form of pathogens and bacteria. Hi, Béla.
Hello, good to be here.
Good to have you. Thank you. John, I'm going to turn to you first. The STRATIF-AI project builds on the current use of machine learning applied to stroke patients to make the response far more customized and time-sensitive. John, healthcare is one of the areas that is most benefiting from AI. Can you tell us a little bit about the goals of the STRATIF-AI project?
Yes, Abigail. The STRATIF-AI project is interested and focused on integrating heterogeneous data sets to drive insights for patients across their lifetime, with a particular focus on how stroke affects them. So we are trying to make continuous stratification, and that's where the name of the project comes from. We're trying to create AI tools that continuously stratify somebody's stroke risk throughout their lifetime and help them to manage that stroke risk and also to have better outcomes after stroke treatment.
Okay, super. How did you identify the patients that you would follow, and how did you enroll your participants in this?
Well, our ultimate goal would be to have broad coverage across a population rather than a particular cohort. We want to be able to take for the whole population to develop tools that are suitable for everybody. That will be able to take somebody through from very young throughout their whole life through to where they've had a stroke and they're in acute care versus reintegration back into society after that care. So the ultimate ambition is for everybody to be supported and enabled through this research.
Okay, fabulous. That sounds really a really good goal. How are you applying artificial intelligence to this? What is artificial intelligence enabling you to do here?
So we're bringing together two different types of artificial intelligence in this research. The first type is called a digital twin model. So a digital twin is the idea of we create a computational model that is personalized to an individual. Creating a digital twin makes the model quite interpretable because of the structure of the model. We're able to understand how the different variables that represent the person's health state evolve through time. But it has some challenges in terms of being able to develop those models to scale to large populations and integrate very different types of data. So we're combining those digital twin technologies with what we call machine learning. So machine learning is a way of analyzing very large data sets to extract patterns and interactions between different features. So by bringing these two types of machine learning and digital twin artificial intelligence approaches together, we're trying to make personalized, interpretable systems that can scale and bring together large heterogeneous data sets so that an individual is able to understand their stroke risk throughout their lifetime and manage it.
Right, excellent. And then also perhaps to receive advice that would enable them to reduce their risk.
Oh, exactly. Yes. So we'd like to be able to, for example, tailor the interventions that are suggested to a person to their stroke risk. and help them to understand across their lifetime how that's evolving and how modifications in their lifestyles can affect that. So I think one of the really interesting things that this might link to is that actually the earlier on somebody makes a change in their life in terms of a stroke risk, the greater the effect it has in a cumulative approach over their life course. So even a very small change very early on in their life, for example, in terms of modifying their cholesterol early on in life, can have a massive benefit across their lifespan. And the earlier we intervene in somebody's life course, the cumulative benefit is much, much greater. So you can imagine that if we wait till later on in life to intervene in somebody's health trajectory, we have to do a more intense intervention, for example, using drugs. So what we'd really like to do is from early on in life, allow people understand their risk and do small changes to their lifestyles that help them to avoid bigger interventions later in life.
And the difference with this, of course, from current sort of approaches from the healthcare system where, you're told to eat your 5 vegetables and fruit a day and, walk however many steps the current thinking is and so on. The difference here is that your advice would be very much tailored to the individual. So you'd be getting a much more textured, in-depth insight into the various things that all interplay together. Is that correct?
Yes. So one of the fascinating things about health and medicine is that while we can extract information about risk factors at a population level, we are all individuals and we are all different, and how they interact within our own systems are different. So trying to make models that are personalized and tailored to an individual to capture risk factors is what we're trying to do here. So for example, you might consider that some people have a genetic predisposition to particular risk factors. And there's aspects called epigenetics where our lifestyles turn on and off genes that cause risk factors, or that exacerbate or amplify risk factors or reduce risk factors. So trying to integrate, for example, genetic information with lifestyle, nature and nurture, if you like, can give us a much more personalized risk for an individual than if we just consider somebody as somebody in a population similar to everybody else.
And of course, the benefit immediately is that with that personalized input, you're far more motivated to follow the suggestions because it is for Abigail Acton or for John Kelleher or for whoever. It's specifically tailored for you. So I think maybe you take it more seriously.
Yes, and actually one of the really exciting aspects of the project is that our partner in Linköping, who's coordinating the project, Gunnar Siderson, they have the idea that we'll take this digital twin, and the nice aspect of the digital twin is we can simulate forward in time your health state. And what we're developing is the concept of a digital twin where there is a graphical interface to the digital twin. And we can not only tell you about how your risk is, but it will evolve through time, but we can also show you graphically to make it much more concrete, to show you, for example, how you would age with this lifestyle versus another lifestyle, to try and improve compliance and interventions to help people and motivate them.
Absolutely. And it sounds very motivational. And is this something that would be on someone's telephone app, for example? Or would it be like a phone app? You'd just be able to pull it out of your pocket and see the choices that you were making, how they would impact on you in real time? Would that be the ultimate goal?
So we have 2 different aspects, yes. One is where you'd have a health vault on your phone, where you can carry around on your phone your own personalized health profile and electronic health record, but also where we'd have a larger graphic display that would be used in an intervention called a health dialogue, where you would go to somebody, maybe every 10 years or 5 years, you'd go in and speak to a nurse or a clinician, and we would be able to simulate there and develop a plan with your input, where we could simulate for you a whole body scan. And we're able to work with you and say, well, if you change this and this, if you, for example, reduce your calorie intake, reduce your cholesterol, this is what happens or that what happens. And with that insight given to you, have a dialogue with you to think about what's the plan you would like to adopt over the next 5 or 10 years.
Fantastic.
So to have patients and clinicians speaking to each other and co-developing their plans for treatment and support.
So collaboration rather than sort of instruction. Fantastic. Do you imagine that digital twins can be used elsewhere in the healthcare process? Are there other applications that you can think of as being useful?
Absolutely. So the really exciting thing about digital twins is their ability to simulate the evolution of a system. So that means for a system here, it could be the evolution of a disease within an individual. So, for example, any types of health where we have a chronic long-term evolution of that disease within an individual, digital twins can support that. But also, if we move away from thinking about precision medicine for an individual, we can also think about, for example, even the logistics of healthcare. So simulating hospital operations and facility management, because the digital twin can simulate either an individual or a physical system. So maybe we can improve the logistics around healthcare, reducing the economic burden of healthcare. But there's also the idea of drug development and medical device simulation. So trying to use these technologies to increase the rapidity in which we can develop new treatments or develop devices and simulate devices and interventions on individuals to check how effective they are before they're deployed.
And what about a digital twin of actually a pathogen? So
Absolutely.
that you could then see the impact of treatment on that pathogen in the form of the digital twin.
Absolutely. So the challenge with developing digital twins, and one of the things we're really tracking or addressing within the challenge, digital twins have huge capabilities and advantages going forward. The difficulty with them is that in order to implement them, we need a theory or model for how a system, a process evolves through time. And that can be difficult to implement. And that's where the complementarity between a digital twin and machine learning comes together. Because machine learning enables us to model some of the interactions on high-level complex interactions that we mightn't yet have a theoretical knowledge for. And integrating that with the digital twin allows the digital twin to model in an interpretable and computation feasible manner the areas that we do understand, but integrate the patterns that machine learning takes from large data to help the whole system work more comprehensively.
Fantastic. It sounds like a wonderful way that AI is pushing back the boundaries of research. Thank you so much, John.
That's why I think that the integration of the digital twins, the theoretically driven, if you like, approaches versus the data-driven machine learning approaches that captured those high-level interactions maybe before we understand them is such a promising approach. This hybrid modeling will allow us to start building systems that integrate both what we understand and what we can model, which are different things at some points, integrating them now, and then slowly, with those initial systems, growing the amount that we understand to be more interpretable.
Fantastic. Thank you, John. I'm going to turn to Jane now. The role of women in early modern Ireland was pivotal in a time of societal change, but the stories of the women, highlighting their resilience amidst social upheaval and trauma, have largely been lost to history. The Voices Project let them be heard. Horizons are also opening up in the humanities thanks to AI. What was the challenge facing you before such tools became available, and what can you do with them now?
The big challenge was really around access to the manuscripts themselves, and then access to material that was available in digital format, but wasn't interoperable. It didn't. These digital silos weren't talking to each other, and it's in those two particular areas that AI really has been very enabling for our work. And I think that the potential is we're just beginning to explore it, but if we can get it right, AI really will be transformational when it comes to doing historical research, not just about women, but obviously our focus is women.
Absolutely. I guess, it seems hard to imagine, even as a journalist, before all of these tools became available and so on. But how would something like this have been done in the past? Would you even have been able to tackle such a large-scale project in the past without such tools?
What AI allows us to do is history at scale, because it allows us to actually interrogate records, especially records around taxation or demographic records, that it's incredibly time consuming to analyse these, or legal records. And what we find is that the women are deeply buried in them, Abigail. So AI is allowing us to identify those women. And once they've been surfaced, if you like, then obviously we're analysing what we're finding. So it really has helped us enormously around the identification and access to non-elite women who, as I say, are very much buried in the records.
Wonderful. And what sort of things were you finding, Jane?
What we're finding is that actually women have been hiding in plain sight all along, and that records that we thought were actually of no use previously, we're finding are of tremendous value. Let me give you an example. We've got things called funeral entries for 17th century Ireland. They're the equivalent of death notices today. And people had never really bothered with them. And what we're finding is over a third of them actually are by women and about women. So all of a sudden, a whole new body of material has been, if you want, unearthed, thanks to our interactions with AI. Or wills, testamentary material. Again, we thought that for a whole variety of reasons that there were no wills by women, or there were very few. And we've now uncovered about 500 of them. Again, AI has been extremely helpful in allowing us, A, to identify them, and then to create digital surrogates that we're then able to analyse and interrogate.
I'm just going to cut across you here because I've got so many, this is so interesting. I've got my brain just seething with questions that I want to ask you. First thing, an observation is it must be a bit like being an archaeologist discovering a hitherto unknown tomb that shines light on the whole kind of culture of that period. It's absolutely fascinating. It must be very thrilling, Jane. Is it thrilling?
Oh, it's so exciting, Abigail. I can't tell you.
Yes, it must
because
be.
You think you're going to something, you're not going to find anything. And all of a sudden, it's a third of the records are relevant and interesting. And these are records that we thought many just didn't exist because in 1922, the archive in Ireland was destroyed. So, I mean, it's one of those ones where all the material is dispersed. In other words, transcripts that are scattered all over the place that we are, thanks to the technology, are able to reconstitute, I think, in a very important and innovative way.
Okay, so you said that the material apparently had been lost. So where did you find it? You scattered transcripts, so duplicate copies found in places that are hitherto not looked at, or?
There are some wills in the National Archives in Dublin that people really hadn't appreciated had survived the fire. So that's obvious.
Right.
But what we're also finding is transcripts that are in private collections or in publications that were published before 1922, which is when the big fire took place.
Right.
So they're in hundreds of different locations, and they're so disparate. And this is a way of taking all of these digital windfalls and bringing them together.
I love digital windfalls. Yeah, well, it must be because wills are such a window onto a society and a culture. For example, obviously, immediately it comes to mind that women had property to bequeath and all sorts of things. Tell me some of the insights you're gaining from looking at such documents.
Well, on the wills front, it tells us a lot about material culture, the property, the jewellery, the household goods. So you've got that side of it, but also it tells you about who women hold most dear, their intimate networks, and how women tend to bequeath particularly movable property, as well as sometimes property, land and fixed assets to other women. So we're just really beginning to recover all of this. And you have to remember, in the 17th century, a woman didn't have her own legal identity unless she was a widow. So and a married woman could only make a will if her husband allowed her to do that. So again, it's giving us insights that we didn't think were possible to find. It's been great.
Yeah, no, it sounds thrilling. Have you any stories or examples that you've dug out that surprised you, or that you feel, well, maybe I can use the old cliche, a bit of a eureka moment about?
We're having lots of eureka moments.
I'm so glad. That's
it's really exciting. And we're only 2 years into the project, Abigail. So when we speak in a couple of years' time, so my colleague who's doing a lot of work on the Irish Court of Chancery, which is the court of equity, where large numbers of women are plaintiffs and defendants. And again, it's so fascinating to see how during usually moments of personal crisis, these women are coming out of the shadows and they're going to court, often to protect their own interests. It might be that they've been given some money upon marriage and a male relative is trying to steal their money or steal their land or steal their property, or they're going to court to protect the interests of their children. Or their reputation. We have one very, very juicy account of a young woman who has entered into a relationship with a man, and she's had a child out of wedlock, and she then marries, and the husband she marries is actually taking her former lover to court for damaging the reputation of his wife. So again, these are the sorts of stories that are usually lost from history. Yes, it gives you, as I say, a very personal insight into people's lives.
Absolutely wonderful. Well, thank you so much for explaining all that to us and setting it out so clearly. Does anyone have any questions for Jane?
I would actually, Jane. I'm fascinated by the Voices project, and I'm really excited by the way you're using new technologies to try and understand the past in new ways, particularly technology that's evolving very rapidly. So I'd really like you to, if you could, to think about or imagine how this AI systems that are evolving so rapidly could be designed in the future to improve and support historical research. And what capabilities do you hope it will have, and how do you think it will enable historic research in the future?
Oh, great question, John. I want a AI system that is transparent. I want the computer scientists, never mind the historians, to understand the algorithms that underlie it. I want an AI system that is ethically bounded, and that code of ethics then protects the intellectual property of everybody who is contributing to it. But the third thing I want is an AI system that is environmentally responsible. I'm so conscious that the current system is so greedy of power and water, and especially generative AI. So as we look to the future, those ethical and environmental issues for me are hugely important. And then I'll feel much more comfortable about being able to trust the AI system that we come up with, because just at the moment, trust is my fundamental objection or concern with AI.
Yes, I think we can all absolutely identify with that. Perfect. Thank you. Bela, I'm turning to you now. Terrorism can take many forms, including biological ones. Bioweapons pose a threat mainly due to detection difficulties, but that's something the HoloScan project is tackling head on. So the project's been using AI to develop equipment to help first responders in an emergency. What problem were you hoping to solve, Bela?
Yes, the problem is mainly discovered by the ENCIRCLE project of European Union. ENCIRCLE project defined the gaps, and in the gaps they identified there is no good on-field tool for biological detection, and we wanted to create a device which can work on field and also possible to use in many scenarios, not just in one scenario. So it's a big challenge, of course. It's over the state of the art, but we started to think about how we can apply microscopy, especially holographic microscopy technology, to fill a gap a bit, even if we not solve the whole problem.
Well, you've made a great start on this goal. Bela, what are the current ways of detecting what might be present in a biological attack?
Currently, the most accepted way to detect is use PCR methods, and also the fluorescent labeling methods, DNA sequencing. All of them needs laboratory preparation. It's a long method, and for example, PCR suffer from false positive results. It means it can signal, it can say it's a danger even if there is not, and this rate is very high, above 20%, 30% for current detectable pathogens. And in sequencing, the problem of epigenetic fragments is currently not handled. It means dangerous fragments can be detected from DNA, but it is not present on protein level. It means it's not really harmful. So
what you mean is that the current systems could pick up fragments of DNA that are not accurate in some way. What's the problem with the picking up of the fragments?
The problem is that we can find dangerous fragments which can coding dangerous proteins. But because of epigenetic information, the cells are not expressing, not creating these dangerous proteins. And it's everywhere around us. In the environment, this code is everywhere, but it's not expressed because of epigenetic locks. So this is why we cannot use sequencing in each case.
I see. So the sequencing might be picking up something that's around us anyway and not posing a problem.
Yes.
But it's identifying it, and then it's confusing the end result because then the responders don't know what they're looking at specifically. Yes, I see what you mean. Okay. So how did HoloZscan aim to help all of this, and how did it use AI?
In HoloScan, we focused on microscopy technology, holographic microscopy technology. Why holography? It's a good question. Because it's let's say it's self-calibrable, it's self-calibrated, creates self-calibrated pictures. It means we can numerically analyze the picture, so we can get values from it under different conditions. And holography gives a very stable base for this numeric analysis. And so we can see exact morphological properties and also optical properties like spectral information and also refractive information of these small objects. And wide range of information we can even not identify but classify the particles. And also we can see complex morphologies around in the sample and around the objects. And from this morphological complexity, with using of artificial intelligence, we can figure out what the situation is. Is it intentional? It is a man-made situation, or it's an environmental situation? So AI can help a lot to identify the real source.
Okay, excellent. So instead of taking little tiny samples to try and identify what the material is, you've developed a system that actually is visualizing the material. And then through the visualization, what's happening then is AI somehow cross-referencing what the thing looks like, what the sample looks like, or the elements within the sample look like, and then is that cross-referencing across another kind of database of similar images and deciding what it is, or what happens next, in fact?
Yes, we started in many lines. First, of course, we used laboratory samples, very clean samples of bacteria and other pathogens, and we created a database and also trained the artificial intelligence to identify this different type of bacteria. And it works very well. On laboratory samples, we can say it works more than 99% of accuracy.
I think you said something about a generation of 70,000 synthetic holograms.
Yeah.
That reflect real biological particles. 70,000, that's huge, huh?
Yes, we created a simulator too, because in laboratory we couldn't achieve all the samples. There are some very dangerous BSL-4 level. BSL-4 level means it is deadly and we cannot cure. So we are not allowed to handle this type of material. So we created simulated samples, how this looks like. And also we could create the type of objects that we can never measure, but in a certain time period, but it can appear in a reality. So with using of simulation of the digital twins, let's say, we extended the training range of the artificial intelligence.
So it's basically synthetic holograms, like a reference library.
Yes, absolutely.
Lovely. So then a first responder takes this device to a situation where they suspect that there's been some sort of biothreat. And what? They take a sample of the air or the sample of the soil, they put it into the canister, or how does that work?
Actually, we focused only for airborne pathogens. So we use air sample collectors, Coriolis-based air sample collectors, and also impactors.
Sorry, what's an impactor?
An impactor is a device when we create an airflow with ventilators, and we put obstacle in the line of airflow. And on this obstacle, the small objects will stick. And we pick it up for if it's a microscopic slide, and we directly can put it under the microscope and analyze.
And that can be done in situ, in real time?
Yes, it can be done in situation and in real time. And also we can integrate together an impactor and a microscope.
Right. So basically you're able to collect data in the field that will then allow first responders to see immediately what it is that has contaminated the area. Is that correct?
Yes, is that correct? And we can analyze the composition of air, which is the most important information for the first responders. And with this composition, we can infer, is it a real threat? It can be a real threat, or it's some environmental variation.
Okay. Well, that's fantastic. So it rules out all these false positives, which maybe cause chaos. And in fact, there's nothing dangerous there and so on. Super. That's excellent. Thank you very much. Thanks, Bella. Well explained. John, would you have a question for Bella?
Hi, Bella. Yes, actually, I'm fascinated by this work. I'm really interested in the aspect where you've used synthetic data. So in my own work, in healthcare, we often use synthetic data to protect people's privacy. But here I see you're using synthetic data because real data will be so dangerous to handle. And I was wondering if the fact that, what are the challenges you face in creating a system to synthesize data where you can't handle the real data at all? You know, I can understand that healthcare, we can take a sample of patient data and synthesize from that to create, to protect privacy. But I presume for your work, there's even more challenges involved in creating a good synthesis system.
Yes, it's a real challenge, as you said. First of all, we had to calculate a microscopic level of light propagation and calculate holograms. It means we have to calculate interferences. It means we used different type of mathematical models. One type of mathematical model is a step-by-step, let's say a step-by-step FDTD simulation, and another type is a bit analytic. It uses some rule of physics which helps to handle image planes as one data information and propagate plane by plane. So we use different mathematical methods and compared them together. This was a challenge to build a model and also to validate it with different simulation and with the reality. So this was the highest challenge, I think.
You see, it takes somebody using AI for their own work to spot that might have been a difficult thing to achieve. Thank you, John. Yes, a very pertinent question. And thank you to you, Bella. Excellent. Well, thank you very much, all of you. This has been really fascinating. And it's so nice to hear about the application of AI in a way that feels that it contributes to our well-being rather than some sort of scary thing coming down the line that's going to take all our jobs. So thank you very much, all of you, for being with me today. It was very, very interesting.
Goodbye, Abigail, Bella, Jane. It's been a pleasure talking to you all. I've really enjoyed it.
It's been an absolute pleasure. Thank you for having me.
Thank you. Thank you.
Thank you. Thanks very much for joining us. Bye-bye. If you've enjoyed this podcast, follow us on Spotify and Apple Podcasts or wherever you get your podcast, and check out the homepage on the Cordis website. Subscribe to make sure that the hottest research in EU-funded science isn't passing you by. And if you're enjoying listening, spread the word. We've talked about the world's largest collection of viruses, using VR in conflict resolution, and whether crickets are going to be replacing the beef in your burger anytime soon. In our last 51 episodes, there'll be something there to tweak your curiosity. So come and check out the research that's revealing what makes our world tick. We're always happy to hear from you. Drop us a line. editorial@cordis.europa.eu. Until next time.